Hello, in this video, we want to take a look at the formula for finding the arc length of a polar equation. So throughout this course, we have had various arc length formulas. We had, at the beginning of the semester, we got the arc length formula for the integral from a to b of the square root 1 plus f prime of x squared dx. And we didn't say it at the time, but now that we have multiple, this is the arc length formula for when we have Cartesian coordinates. When we're given functions in x and y. Not too long ago, we then also got the parametric formula for when we have parametric equations of x equals f of t and y equals g of t. We can then find the arc length by taking the integral from alpha to beta of square root dx dt squared plus dy dt squared dt. So this is going to be an integral in terms of t. And the last one is finding the arc length of the curve with polar equations r equals f of theta from a to b. This formula looks very similar to the others. It is the integral from a to b of the square root r squared plus the derivative of r with respect to theta squared d theta. So it's another formula very similar to the others that we can use to find the arc length. So in our example, suppose we have the polar curve r equals 8 cosine theta, and we want to find the length between pi over 6 to 3 pi over 4. Then, using this formula, what we need is we have r. We also need dr d theta. So dr d theta is the derivative, and the derivative of cosine is negative sine. So dr d theta is negative 8 sine theta. Setting up our integral, the length equals the integral from our bounds, pi over 6 to 3 pi over 4, of the square root of r squared, 8 cosine theta squared, plus the derivative squared, dr d theta, negative 8 sine theta squared, d theta. Multiplying this out, we have the integral from pi over 6 to 3 pi over 4 of the square root of 64 cosine squared theta plus 64 sine squared theta. Negative times negative is positive. And since we have a 64 on both, we can pull that out and take the square root to get the integral from pi over 6 to 3 pi over 4 of 8 times the square root of cosine squared theta plus sine squared theta, d theta. We know cosine squared plus sine squared is 1, and the square root of 1 is 1. So that square root is all 1, and all we're doing is taking the integral from pi over 6 to 3 pi over 4 of 8. And this is essentially our easiest integral of the entire semester. The integral of 8 is 8 theta from pi over 6 to 3 pi over 4. Plugging in those bounds, we have 8 times 3 pi over 4 minus 8 times pi over 6. And simplifying this down, we get 2 pi minus 4 pi over 6 not 2 pi, it is 6 pi. There we go. We have 2 from 8 divided by 4. 2 times 3 is 6 pi. So 6 pi over 4 pi over 3. 8 divided by 6 is 4/3. And combining these into one fraction, we'd have 18 pi over 3 minus 4 pi over 3 with a common denominator, giving 14 pi over 3. And there is our example of using the arc length formula to find the arc length of a polar curve.